right? Denaturation. The last week we have discussed about the denaturation. What happened to the denaturation? There is a normal protein is there, and because of the some kind of the action, maybe there is a different type of environment actions come to the protein from the outside, not in the inside. Therefore, it can be changed. Therefore, normal protein can be denaturation, and denatured protein is it's open there the what's the active sites, as well as then it's because of the active sites open, it can be able to work with the or the interact with the other molecules. And the some proteins after denaturation, so those can renaturation, and some are they completely denaturation, and it is unable to turn back. For example, that we mentioned about the boiled egg, or the sometimes we or the boiled meat, or the boiled what is the legumes proteins available, and these kind of thing we can't make it back. But in some situation, for example, let's say if we are using the shearing force for the egg proteins, it can be turn back, because you have seen it even that the small bubbles form, but later on it's after breaking down that that you can get the liquid egg, right? So the shearing force, but if you are introducing shearing force very hardly, sometimes you can't get it back. But if we are using the beating, very soft beating, you can get it back. So those things are some information or some example for the how denaturation happening and how denaturation is happening. Right. Now you know that the denaturation process and what is happening there. And therefore, today we are going to discuss about the what is the denaturation not the what is the denaturation process. We are going to talk about the what are the agents, or how we can change the denaturation, or how we can support the denaturation process. Because I mentioned you, denaturation process is really important. To the reason is, without denaturation we can't go for a different type of products, or the product manufacturing, or different type of action. Now we can't get the action of the protein, right? So the denaturation can be brought about by variety of agents. So what are those agents? The one is the heat, that is most important, causes the denaturation of enzyme activity, even because proteins also the kind of enzyme. Therefore, heat is most important. It's once we subjected this protein to the heat, then sometimes we can't make it back, right? For example, in some situations, or the meat, or the fish, or the boiling egg, or this kind of thing, even we can't take it back. The other thing is, after denaturation, it is because biological sites are very active, and biological sites are in the not the boiling, heating, because of the heating, but however it's easy to digest. Therefore, the heat is really important. The other one is pH, the salt or the urea, the surface effect, the whipping or the pressure, and the solvent alcohol. I remember that the last week I mentioned that one student asked that how pressure is supporting for this situation, and I mentioned about the in relation to the sausage. I think I mentioned that to your group, right? Because I'm also parallelly doing the lectures to the food chemistry, also the protein. Therefore, I'm sometimes I think it's to you, right? Then the pressure, and in the case of sausage manufacturing, even we want to put pressure to get it or the close to each other, and thereby so we can make the links. And because in the sausage manufacturing, even we are introducing some enzymes, the glutaminase enzyme, and because of the glutaminase enzyme, you can glutaminase enzyme and the pressure, you can get the very nice structure of the protein. In the other case, even the surimi production, even we want to use some pressure to make it together, and therefore we can get a very nice structure of the product. And also the other one is the solvent alcohol. I mentioned that the DNA, that the bacteria also having the protein, therefore the once the protein denaturation, the bacteria is going to, we can't, kill the bacteria like solvents, alcohol, right? But, right. Then the denaturation usually involves loss of biological activity and significant changes in some physical and functional properties, such as solubility, and usually this is non-reversible. And there is some situation, heat denaturation, sometimes desirable. In which situation the denaturation of whey protein for the production of milk used in baking, and proteins of egg white are readily denatured by heat, and then the egg white is whipped to form, and meat proteins are denatured in the temperature range 57 to 70, which has profound effect on texture, water holding capacity, and shrinking. So these are some examples, and you are really know this example in your normal because day-to-day life. So you have experienced these things, and in the last example, the meat proteins are denatured in the temperature range 57 to 70. Then you have to see that the texture of the protein is totally changed. And also because of that, the water holding capacity is going to reduce. And you can see once you cook the meat product or the fish or these kind of protein-rich products, so you can see it's getting shrink. Right? Shrink means getting smaller, and because of the breakdown of the protein, and therefore the trapped or the bound moisture can be going out, and H2O molecules and hydrogen bondings are broken down. Therefore, also the H2O can be released from the product. Therefore, you can get the shrinkage of the product. Then the denaturation may result in flocculation of globular protein and to the formation of gels. I have discussed this one also. I think you have to remember that we have discussed about the flocculation of globular protein, and that is why gels can be formed. Right. The protein denaturation and coagulation are aspects of heat stability that can be related to the amino acid composition and sequence of the protein, right? So this denaturation and coagulation are some amino acids and the proteins are very stable, heat stable. So therefore, these are not supported for supported for denaturation process. I mean, they're not the milk coagulation or those things are not happen because of those protein and amino acids are really helpful, really strong for a heat some denaturation process. Not all the amino acids, not all the proteins, but some are really very stable. Right. So therefore, we are using these properties of the protein for product manufacturing. So the effect of heat usually involves a change in a tertiary structure, leading to a less ordered arrangement of the polypeptide chains. Right? And the temperature ranges which denaturation and coagulation of most proteins take place around 55 to 75 degrees. Caseins and gelatin are example of protein that can be boiled without apparent change in stability. So you can see this the milk, or even boiling milk, even you can observe that so nothing happened to the milk because you can boil it, but if you are overboiled, so you can't get the things back, but you can maintain that situation. And you know that how we prepare the milk maid, right? Milk maid is once you dissolve in the milk maid in water again, you can get the milk, right? Not the same one, but however you can get it a liquid milk. In the case of milk powder, even once you dissolve it in the water, you can get the again the milk, but it is not the same milk what we have used for preparation of the milk powder, but you can get it back. So therefore, because the reason is the casein available in the milk protein is really heat stable. Therefore, it is supporting to get it back once you dissolve in the water. In the case of gelatin, even so, it is also heat stable, and that gelatin you can heat it, and once you heat it and once you keep it again or cool it, You can denaturation, but it can trap the water. So therefore, those things, once you remove the water, even you can get the gelatin back. So those are some proteins. Those are not stable for the heat. If not so, the most of the proteins are not stable for the heat, especially meat protein available in the meat, protein available in the fish, or protein available in the legumes. Those are not heat stable. Therefore, those things can't get back, right? Can't get back to the real situation again. The albumin, egg, those kind of things. So the example for the exceptional stability of casein, if we discuss about that, make it possible to boil, sterilize, and concentrate in milk preparation without coagulation. So what is the reason in the first place? Restricted formation of disulfide bond due to the low content of cysteine, and cysteine results in increased stability, right? Cysteine results in increased stability. When you are comparing the structure of the cysteine is having disulfide bond. Therefore, because cysteine, if the cysteine is very less available, limited, or the low availability of in the milk. Therefore, once you heat the milk, even that it is not supportive to prepare the naked disulfide bonds, right? Because cysteine is not available, and therefore it is having an increased stability. Because you know that once the disulfide bonds, hydrogen bonds are broken down, then it can be formed again. But in the case of sulfide bonds, it's once broken down, it is very difficult. It is not you can't get it back. So that is why the other things are having sulfide bonds a lot in the albumin or the meat protein, fish protein. Therefore, those once you boil it, you can't get it back. But the thing is, milk is having the casein. Therefore, you can get it back. Extremely low content of sulfur amino acids are less likely to become involved in the type of sulfur-hydryl agglomeration. That is also the other reason, because sulfur agglomeration also supporting to get it coagulate, but because after breaking down the sulfur bond, so they can try to get the agglomeration. But in the case of milk, as there is a less sulfur amino acid, therefore it is not happening in that tree. Restraints against forming folded tertiary structure. And these restraints are due to relatively high content of proline and hydroxyproline in the heat stable protein. Right? Therefore, if you are going through the amino acid content of the milk and fish, egg and meat, then you can understand that the protein amino acid composition is totally different with the milk and other things. So that animal protein, so the animal protein means milk is different one when compared to the muscle proteins, and therefore that is why the stability is there, high content of proline and hydroxyproline in the heat. Those are also heat stable proteins. Therefore, when we talk about the heat stable amino acid, when we are going through these things, the casein is there, proline is there, hydroxyproline is there. Those are very stable one. Therefore, the sulfur amino acids are very less in milk. Therefore, exceptional stability of milk you can see because of this situation. When we talk about the protein quality, proteins with a relatively high content of essential amino acids are called first-class proteins, so high-quality proteins. So if it is in the nutritional point of view, we talk about the essential and non-essential. So what is the essential amino acid? Those are called first-class protein and high-quality protein. Quite expensive to produce, that in the red meat, white meat, dairy products, eggs, and a few legumes, peas, and soybeans having this high-quality protein. Animal proteins usually contain much more of the essential amino acids than do plant proteins. right? And intermediate quality proteins are those derived from material like potato, rice, wheat. Those are having the intermediate quality protein. And also poor quality proteins are derived from millet, sorghum, cassava, and other roots and tubers. Therefore, it's a protein, when we talk about the protein quality, that the high quality proteins, intermediate proteins, and the poor quality proteins are there. However, the action of these proteins are also not much different, but we can't say it's not much different, but however, it's a difference is also there. For example, when we talk about the wheat flour having the gluten protein, wheat flour having the gluten protein, and gluten is having a different type of proteins, right? Shaminu, can you ask the question? You can unmute the phone and microphone and ask the question, Shaminu, it's no problem. Yes, there is another question asking that the sulfur-hydryl agglomerization. Sulfur-hydryl agglomerization means that once the sulfur bonds getting breakdown or the bonding even, it's the agglomerization means getting together. So that is because of the sulfur SH bond, SS or SH bond, it can be getting together. We call that the sulfur-hydryl agglomerization. Now, when we talk about the essential amino acids, histidine, isoleucine, these are the, I think those 10 amino acids are there. And I think you have remembered those things because in the nutrition classes, so you have to learn these things and also in the table, right? Now, let's discuss about the environmental effects of protein and protein quality, and the environmental can exert profound changes on the functionality and nutritional quality of the protein, right? That means functionality of the protein as well as nutritional quality of the protein can be changed because of the environmental effect. So when we mentioned about the nutritional quality means in some situation that some amino acid, if we change the amino acid totally, then nutritional quality can be changed. If not, normally the functionality only change, because we mentioned in some point in one point that because of the environmental effect, we can't change the peptide bond. We can't change the peptide bond, but we can change the activity of the protein. Peptide bond is there, but we can change it back, because you have seen that how that once the peptide bonds are breaking down, what happened to the protein structure. You have seen that the alpha helix and the beta sheet or the tertiary protein, and what's happened, tertiary protein and quaternary protein, you have seen that. So once they broken down to get those together, so you can see one by one peptide chains are releasing. So that is why that you can see that how proteins will be changed because of these environmental effects. The degradative reactions can result from a processing or storage environment, which can cause undesirable changes of protein. Degradative reaction can be happen, and because of the frozen. We will talk those things later on. As a result of this reaction, protein can exhibit loss of functionality, loss of nutrition quality, increases of toxicity, as well as desirable and undesirable flavor changes. Right? So so what is the desirable and the undesirable flavor changes of the protein happening because of this environmental effect? Can you let me know two things? What are the desirable things can be happen, and what are the undesirable things? So what is okay? So if I pass this four question as a result of this reaction, protein can exhibit these at least these four points, right? Four things. So if I ask the question, so as a result of environmental effect of protein quality will be losing. then what kind of, can you explain this thing, or can you discuss the effect of environmental changes on protein quality? Can you discuss it? If you are going to discuss it, then what are the points you are going to mention under that? Yes, very good. The one is the Maillard reaction. Yeah. So if we are talking about the Maillard reaction, very good answer. Because of the Maillard reaction, few things can be happen. So what are those? Under this list, few things can be happen. What are those? Whether it is everyone can participate for the lecture and give the answers, right? Therefore, we can speed up the lecture. If you have really put your mind to the lecture, then you can answer. So the Maillard reaction is a good answer. Then because of the Maillard reaction, what can be happen? Nice flavor as well as nice aroma can become. Yeah, that is the desirable flavors can be changed. So what are the undesirable flavors? Not because of the Maillard reaction. Students, toxicity can be formed because if you are going through the Maillard reaction later in a later stage, so you can get the toxicities will be there. Color is a very nice color you can get, correct? What else? The one student, please unmute your phone. Sorry, mute your phone, microphones. Surrounding voices are coming, not the voices. Roshima, can you check who is the person, not the mute their phones?
Okay, madam.
Yeah, please check, go through it.
Oh, now they all have muted their phones.
Yeah, muted. Right, thanks. Then, right. Okay, as you have given some answers, I will going to explain these 4 points. Losses of functionality. So, what are the functionality? Functionality means that means hydration. I mean what's the solubility is the one function. Gelation is one function. Forming is one function. And then viscosity and what's the cohesive adhesion, that the linkage with each other, and surface tension, like those things are the functionality. So those things can be lost, or the losing can be lost because of the environmental effects. The nutritional qualities we can discuss that the Maillard reaction, the lysine, the amino acid is supporting for the Maillard reaction. Therefore, lysine is very essential one, and that is also releasing from the product. So it is no more because it's support for the Maillard reaction, and because of that even that the toxicity can be formed. And not only that, because the high amount of sulfurlyl compounds even giving sometimes the toxic, because some amino acids are not really good, because in some situation, let's see now, histidine amino acid can be changed to the histamine. Therefore, that is also producing toxic. Toxic means not the toxic, the visha, but it gives the allergic situation for the people. And histamine is all right, but because of that situation, histamine can be removing from the environment. So from the product. The other one is desirable and the undesirable flavors is then some sulfur flavors are coming because of the environmental effect, right? Because of enzyme activity, that the sulfur related compounds can be released, especially that is why you can see that during the spoilage or deterioration, you can see meat, fish, milk, that the unpleasant flavors, smelly flavors, the amine flavors is coming because of this situation, right? Those situation also not good. But you have to later on, you can discuss a lot regarding this point. So the environmental changes that can adversely affect proteins include heat in the presence and absence of carbohydrate, that is Maillard reaction, extremes in pH, particularly alkaline. So the even that also can totally denature protein. So if you add some urea in or the high alkaline solution, that it is effect or the break down the peptide or the protein structure can be breakdown. The other one is exposure to oxidative condition caused by light and caused by oxidizing lipids, even that the double bonds available in the, not the peptide chain, but the side chains, there are some double bonds, those can be changed, right? Therefore, you can get some colors even can appear after that, even if you boil the meat. So the hemoglobins, globulin, so those hemoglobin also, the protein also can be changed. That is why you can get the different color because of the heat. And even if you heat a lot, that the milk, even you can get the yellow color, right? Some pigments are producing, and therefore and because of the light effect, that you can get the different colors of the protein, especially the yellow color. And the other one is nutrients are destroyed when food are processed, large because they are sensitive to pH of solvent and sensitive to oxygen, light, heat, or combination of these. Other one is the amino acid composition of food protein is of fundamental importance in determining nutritional quality and functionality. Therefore, the amino acid composition of food protein is a fundamental importance. If you are the taking or the eating the protein rich food, is the very basic importance is we want to get some nutrition protein we want to get to our body. That is why we eat protein. But if something during the processing or during the because of the environmental effect or because of because of taking different steps of during processing, most probably we will lose the quality of the protein. Therefore, if we know some situation, then we know what kind of good steps we have to take during the protein processing. Interest of processing on proteins are the one that's different proteins and food systems have very different susceptibilities to damage resulting from processing. Students, have I discussed this point with you, these intrinsic factors, extrinsic factors, and processing factors? Have I discussed with you? Have you remembered these 3 slides? Have I discussed this slide with you? This one? Oh, I have discussed this one. ඔගොල්ලෝ තමයි අද වැරද්දුවේ. right? මම මුලින්ම අහුවනේ මොනවද කතා කරේ කියලා. අපි මැද්දෙන් පටන් අරන් තියෙන අද ලෙක්චර් එක. right? සාමාන්‍ය. මේ ටික කතා කරලා පිටිපස්සට එමු. right? Then it will be much easy. Now we are going to talk about the influencing of processing on proteins in relation to the processing factors. So what are the processing factors? So dehydration, canning, baking, or domestic cooking, or the whipping, the beating, or the so different type of things. So the can be used as a processing factors. So different proteins and food systems have very different susceptibilities to damage resulting from processing. So the processing is really the processing, even the desirable and the undesirable activities are there during the processing. So in the most commercial process such as dehydration, canning, baking, and domestic cooking have only small effect on nutritional quality of the protein, right? So once we remove the water from the food product, but it is not definitely not damage the protein quality of the product, because we are not going to damage the peptide chain, and also, even though the peptide chain damage, we are not going to damage the amino acid composition, amino acid molecules. Therefore, the commercial process or these kind some dehydration process is not effect for a protein, the protein quality. Protein quality, I mean protein quality, whatever the protein we are going to get to our body. In the case of canning even, so if the dehydration, you have learned that we can do the dehydration by operation by drying under the sunlight. But if you are drying under the sunlight, sometimes it can be changed, because under the sunlight we are exposed to the product to the UV light. But dehydration can be happen, we can do it by using the oven, right? Or there are some different type of dehydrators are available in the processing industry. They are not using the UV light, just the thermal or the heat air we can pass, we can send through the product by that oven. Even we can get the moisture, we can remove the moisture of the product by sending the direct heat. Direct heat we can dehydration, as well as the by using the hot air even we can do the dehydration. And also we can do the dehydration, vacuum dehydration we can do, because during the vacuum dehydration we use the low temperature, but we can observe getting out the all moisture, right? So the commercial process, vacuum dehydration we can do, direct heat we can do, also hot air we can use for dehydration. And also in the normal domestic situation we can use the um, what is what is that sunlight, right? So those dehydration process are not effect for the nutritional quality of the protein. Nutritional quality of the protein means we are not going to change the amino acid profile of the protein. In the other case of the canning, in the case of canning, we use the high temperature. But though we are using the high temperature, that we are not going, the protein quality will not be affected, because it's breaking down the peptide chain, breaking down the structure of the protein. But we are not going to, we can't change the amino acid profile. So therefore, amino acid, therefore it is not also not effect for the nutritional quality. Even the baking, but in the case of baking, it can be affected because of the Maillard reaction. Some proteins are small effect. Some proteins are going away from the system. That means the bread, even the surrounding proteins will be losing, but inside protein is there. And domestic cooking, even sometimes if you are using the different, we put the vinegar, or especially we are not going to put the alkyl, much alkyl, but if you are going to low pH and high heat, and then it is also some proteins will be losing, but very small effect will be there, right? Those are the commercial process and the domestic process. The quality of the protein will not be loosened. The other one is, there are exceptions, for example, condition where food are exposed to the very high pH, extreme heat, and peroxidizing lipids. In that situation, that protein quality can be changed, right? Because very high pH if we are using, definitely it will be affect to the protein quality. Quality means the protein can be broken down, right? Amino acids can be changed a little. and the extreme heat, and also the peroxidizing lipids definitely breaking down the double bonds and form peroxides. Therefore, those things are not available for the for getting absorbing as amino acids to our body. And the physical and chemical environments that protein is exposed to during processing can result in a wide variation of the variety of changes. So the first one is changes in amino acid side chains. So the physical, if we change the environment, physical and chemical environment is exposed to during processing. If we use the physically, if we are damaging in the physically mean here actually the if we are introducing shearing forces even in a very high the beating or these kind of thing, or the chemical environment can be changed the amino acid side chain. If the amino acid side chains can be changed, that means proteins are changed, because amino acids mean totally that the head and tail should be there, side chain should be there. If the side chain change mean it is not amino acid, no more amino acid, so it's a different molecule. That is why the changes in amino acid side chain means change the protein, or the amino acid mean protein will be changed. Amino acid racemize and develop new crosslinks in alkaline solution can be happen, because in the alkaline solution new crosslinks can be formed. So that is why it's mentioned high pH, low pH, high pH even, that can be changed because high pH means the very base situation. Then the different molecules can be formed because of this amino, because once that sulfuric SH bond can be changed, and different hydrogen bonds can be changed, can be broken down, and those things get together and make a different molecule. Then those are not a protein, no more protein. Losses of in nutrient quality, you know about that. Significant changes in functionality can be happen. So I will let you know what are the functionalities. Then arginine, cysteine, threonine, serine, and cysteine are those are very susceptible and very quickly can be changed. So you have to, I will give you a homework, and here arginine, cysteine, threonine, serine, and cysteine. So please go through these amino acid molecules and see how these proteins can be changed because of the physical and chemical environments. Right. Then glutamine and එක තමයි ඔයගලන්ට අපි කියන්නේ mute කරන්න කියලා ඔයගලන්ගේ phones, right? ඒවල කට්ටිය කතා කරන ඒවත් recording වලට යනවා, ඒක පස්සේ publish වෙනවා. Then glutamine and asparagine are determined under alkaline conditions, right? These are glutamine and asparagine are under alkaline condition. So these things not not working, it's broken down, and therefore these two things destroyed. Then especially that the glutamine is really supporting for that amino acid is really supporting for linking with each other. That means the cross links are forming glutamine and asparagine, and it is not happening because of change in the environment. Therefore even we want to make good cross links with the protein and having a good structure, we want to maintain the real chemical and physical environment in that situation. The question is that the arginine, cysteine, threonine, serine, and cysteine, those go through this structure of the amino acid and see why these 5 amino acids are susceptible to physical and chemical changes. So why those things are quickly damaged because of the environmental changes. Once you go through the structure, you can find out because of these things, though these things can be changed very quickly, and therefore these amino acids can be changed. So you can find out that one once you go through these structures, right? In acid solutions, tryptophan is rapidly destroyed and serine and threonine are slowly destroyed. In the other case, that one also you can study by yourself. Then ultraviolet light destroys tryptophan and tyrosine and phenylalanine. So you see that the tryptophan, tyrosine and phenylalanine, what is the amino acid structure and how it can be happen. So those things, once you get some idea, so you can see, okay, that is why we can say chemical and environment, physical and chemical environment can be change the protein very quickly, right? That means if amino acid is damaged, means protein can be damaged. So if the amino acid is not damaged, or then protein is the neutral quality of the protein is there. Therefore, you have to consider this situation because the names are given here. So you have to go through it very easily. Sulfur amino acids are damaged by reactions, products, lipid oxidation, or by the addition of bleaching or oxidized agent. So if we are using the bleaching or oxidized agent during the processing, then the sulfur amino acids can be damaged very quickly. And if the sulfur amino acids damaged, means then that amino acids are removing from the environment or from the system, so you can't get it as a from nutritional quality is not there, no more there, because sulfur amino acids are damaged. Therefore, when we are talking, when we use the protein for different product manufacturing processes, we have to consider this situation, or what will happen if we add the more high pH, if we reduce the pH, if we increase the pH, or if we are going to give the high shearing forces or kind of thing. We have to, if we are going to introduce high heat, those things we have to consider. That means a processing situation you have to definitely consider before you are going to use this processing condition for the process product development. Then all amino acids, especially lysine, threonine, and methionine, are sensitive to dry heat, browning, and radiation. Right? Therefore, these things, the browning means here the dry heat, and browning means the direct heat. If we are going to give the direct heat, even the browning can be happen. So and also the radiation. So those amino acids can be changed due to the radiation even. Radiation means in some situation we are subjected the product for the irradiation. So the irradiation also can damage these things, right? And in the case of irradiation even, definitely bacteria, yeast and molds can be destroyed, because irradiation damage the proteins inside DNAs in the protein inside that the bacteria, yeast and mold. So that is why irradiation is really effective, and you can keep product for you can get the longer shelf life of the product. But if it is a protein product, definitely protein can be damaged. Not a large scale, but however some proteins can be damaged. But in the case of the bacteria, mold and yeast, those DNA can be changed. Therefore, irradiation is or the radiations can be changed the amino acid conversions. Right? They can kill the bacteria. Those things. Right. Keeping now, we have started from this point the denaturation process. So the denaturation process can be happen because of the right of reagent, heat, pH, urea, or these salts, surface effects, pressure, and also the solvents, sometimes the alcohol. And we have discussed these all the things in detail, what will happen, and we have taken many each and every amino acids and discuss about things. So what happened to these amino acids if we are subjected these amino acids to different situation. So you have to these things you have to study put much effort and study, because though we have studies all the structures, amino acid profiles and everything about the proteins, but in the nutshell, the protein functionality is really important when we talk about the product manufacturing or the product functionality, right? Therefore, let's see now from these points. When we talk about the protein, what are the functional role of food proteins? That is really important. So functional roles are important. Now, functional roles can be changed if amino acids will be changed. If the proteins will be changed, then the functional roles will be changed. Protein means we know that four structures are there in the protein. That the four structures, whatever the normal situation change, that means the functionality will be changed, right? So the one function is, the functions are here listed in this table in the left hand side: solubility, viscosity, water binding, gelation, cohesion addition, elasticity, emulsification, foaming, fat and flavor binding, right? So what is the solubility? The protein solubility. What do you mean by the protein solubility? That means protein can dissolve in the solubility, means always protein soluble in the water, right? So the solubility can be happen. Mechanism is hydrophilicity. Hydrophilicity means water loving, and therefore if the protein is happy to link with the water, bind with the water, then hydrophilicity is there because of the connecting with these H2O molecules mean hydrophilic. Hydrophilic amino acids can be joined with each other, making hydrogen bonds. Therefore, the solubility can be happen. So I mentioned you solubility mean always that the linkage should be there with the H2O molecule. So the function solubility is given because of the mechanism hydrophilicity of the amino acids. If the product is having more hydrophilic amino acid, definitely solubility will be increased. The second one is the viscosity. If the viscosity can be changed in the different situation, because of the mechanism of water binding, hydrodynamic, size and shape, right? When we talk about the mechanism first, it is mentioned the water binding. That means viscosity can be changed. Viscosity means the thickness of the product, or whether it's flowing whether the liquid is, or is whatever the product is flowing very slowly, or whether it is moving or the flowing very sweetly. For example, the one is, let's say, the raw egg white. Egg white is flowing slowly or fastly compared to the let's see, the minced meat. Because those are having the even that the raw egg is having also the 90% water, and the fish also having a high amount of water, 80% water. So what is happen once you mince කියන්නේ blend කරලා ගත්ත එක, mince කරලා ගත්ත meat fish එකක් ගත්තා කියන්නකෝ, that one, and also the raw egg, white egg. So which one is the viscosity is high? Definitely in the minced fish. So what is the situation? Size and shape of the proteins are different with the raw egg white and the fish meat, right? Minced fish. So that is it. So what is the reason? Size and shape of the proteins. The shape means that the whether it's the primary, secondary, tertiary, or quaternary. So what kind of proteins are there? Size means the smaller protein, smaller molecular protein, or the higher molecular protein. So then also it can be changed. I have shown you, and yes, I have shown you that what is the molecular weights of the protein. So how many units are there? So the 1 unit, 2 unit, 3 unit, 4 unit, likewise. So I have listed it last time, I think, to your group. So because of that, you can find out that if the size is big, definitely movement is low, right? So have you seen that there are some molecules with the 12 unit? I think I have shown it to you, right? Am I correct, Roshema? Have you remember?
Is it a picture, madam? I cannot remember that kind of a picture.
No, it's a table.
No, madam. The size of the protein.
Yeah, the units, subunits are getting together and make it maybe other group, right?
Yeah,
Because
maybe for the food chemistry group.
food chemistry group, yes. I will show that the table actually is real, right? Okay. So therefore, the size and the shape of the protein is really important for the viscosity. And the hydrodynamic means whether it's moving very fast or whether it is moving small with the water. So hydrodynamic and the water binding. So all those effects are very support for the viscosity of the protein, thickness of the protein, and the flowing of the protein. In the other cases, the water binding ability function is the water binding, and the hydrogen bonding and ionic hydration is supporting for the water binding. If the water binding, if the protein, the amino acids is having the very easily those amino acids are bonding with the having the hydrogen bonding and the ionic hydration, then water binding ability will be increased. Next one is the water entrapment and immobilization network formation, right? So in this case, actually, the immobilization means can't moving, and if these proteins are happy to once it denaturation and make the what's the network, and during in that network they can trap the water. So if they can very easily denature, as well as then they set back again, if they can trap the water, then gelation will be happening. Therefore, if the protein is having this kind of immobilization abilities, water entrapment abilities, and the network formation abilities, definitely gelation is there. The other one is cohesion adhesion, hydrophobic, ionic, and hydrogen bonding. If they can form it, then cohesion adhesion function is there, right? Then because hydrophobic groups of the proteins and ionic and hydrogen bonding is two different things. If the hydrophobic effect is there, then it is supporting to remove the water molecules from the system, right? Remove means it's hydrophobic proteins can be get together, and hydrophilic enzyme or hydrophilic amino acids are going to use in a different way. Therefore, accordingly the arrangement can be changed. I have shown you in the earlier that how that in the peptide chain hydrophilic and hydrophobic amino acids are getting together, and therefore they can be curved or they can be folding, and these things are supporting for the cohesion and adhesion. Next one is function is elasticity, and mechanism is hydrophobic bonding and disulfide cross-linking. Because of the disulfide cross-linking, actually the texture, elastic texture is given by these things. Because once you press it, it can be come out because of the elasticity nature. Elasticity is given by the disulfide cross-linking, not the hydrogen bonding or not the other bonding, especially if the sulfur available amino acids are there, that means disulfide SS, disulfide cross-links, those things are there if the elasticity is there. For example, meat, fish, and boiled egg, and you can see because of that the texture is given by the disulfide bonding. And these disulfide bond, the sulfur rich amino acids are not available in the legumes, right? So the not much available in the legume. That is why you can't see that the hard texture of these legumes. But the animal proteins is having high sulfide content, sulfide rich amino acid. Therefore, hydrophobic bonding as well as the elasticity will be there. The other one is emulsification, absorption, and film forming at interface is given the emulsifying activity. So we are talking about adsorption, right? Adsorption, and that means getting water, adsorption and it's not the absorption, right? It's absorption and film forming and interface. That means protein is having the polar head and also the non-polar tail. So therefore it can be act as emulsifier because polar head like it's a water film, therefore it can be bind with water, and non-polar tail of the side chain of the amino acid can be happy to link with the lipids part. Therefore, emulsification function is given by the amino acid because of it is having the polar polar peptide area as well as the non-polar side chain. The other one is a forming function is giving because of the interfacial absorption and film formation is there. Because interfacial absorption is because it can be make a very thin form or very thin linkage with each other, and therefore therefore it can be make a film formation. This can be actually if you are going to if you are wash I think even protein මස් කෑල්ලක් හරි මාළු කෑල්ලක් හරි ඔයගොල්ලෝ පොඩක් වතුරේ දාලා හොදලා බලන්න නිකන් හොදනකොට ඔයගලන්ට නිකන් wash කරනකොට අම්මලා හොදනකොට ගිහලා පොඩක් බලන්න. So you can see that the very thin forms are forming. පුංචි පුංචි bubbles හැදෙනවා. ඒ bubbles එහෙම ඔයගලන් try කරාට එහෙම ඉක්මනට කැඩෙන්නෙත් නැහැ. ඒ අර සබම් පෙන වගේ සබම් පෙන නම් ටක් ගාලා it will be broken down නේ. ඔයගලන් සබම් පෙන එකට පොඩ්ඩක් ඇඟිල්ලෙන් යන්නොත් එහෙම මේක කැඩෙනවා. නමුත් ඔයගලන්ට අර මාළු හරි මස් හරි පොඩ්ඩක් හොදනකොට එන්නේ ඒ පෙන අරගෙන පොඩ්ඩක් අල් බලන්න ඒක ඇවිල්ලා වගේ ඇඟිල්ල වටේ එතිලා තියෙනවා මිස ඒක කැඩෙන්න උත්සාහ කරන්නේ නැහැ. Because those are really that forms are really stable. පස්සේ දැන් උයනකොට සමාන රත් වෙනකොට නම් කැඩි කැඩි යන ඕගලන් දකින්න නැත්නම් ඒක පොඩක් කොලවනකොට තියෙනවා. අද very interesting one is that in the egg white form that forms, and those things are really difficult to breaking down. ඔගොල්ලෝ ඇඟිල්ල දැම්මත් ඒක කැඩෙන්නේ නැහැ. ඒක ඔගොල්ලෝ ඇඟිල්ල වටේ වැටලා තිබ්බම ඒක කැඩෙන්නේ නැහැ. So therefore that interfacial absorption and the film formation ability of the because of that ability of the protein, the forming function will be given. And other one is the hydrophobic bonding and the entrapment is there. Therefore, because of the hydrophobic bonding, because flavors and the aroma and the lipids, those are the hydrophobic one, right? Therefore, because of the protein is having the hydrophobic bonding as well as the entrapment ability, it can be entrap the flavors and the fat. So the entrapment means because there is a very air pockets in some products, even let's say now some flavoring one, capturing let's say the marshmallows even. So marshmallows even that it is also when you are adding marshmallows is a gelatin or you are using, and different if you are producing different type of gelatin based products, so those can very happily trap the flavors and the aroma, right? Especially I think you have tasted those kind of things, especially marshmallows. I think many people they eat it, and those are the marshmallows is not there is fat is no there is no fat actually, there is the gelatin can entrap these flavors. එකයි gelatin වලින් හදන ගොඩක් කැමරා රහ තියෙන්නේ අර රසයි සුවඳයි දෙකම එන්නේ. So because it can be trap the flavors and flavors as well as the aroma. And because of the fat binding ability, so the hydrophobic bonding, if they can form the hydrophobic bonding, therefore it can be easily bind the fat. So that is why again that the emulsification ability is there, because of the it can be linked with the fat, because always the amino acid side chain, if it is a aliphatic one and the what is the non-polar one, it can be happy to join with the fat. This graph showing that the functional roles of food proteins in food systems. the mechanism and the foods and the protein types all are given here. The solubility, mechanism, hydrophilicity, and food is beverage. For example, protein type is whey protein, right? That means milk based, all the product is having the solubility activity. You can add water and also you can remove the water. Again, you can add water, you can remove the water, and different type of milk based product you can produce because of this hydrophilicity ability of the protein. It is available in the whey protein or the milk, right? When we come to the viscosity, you can see the gelatin, protein type gelatin. Food type is soup, gravies and salad dressing and dessert. Gelatin is added this kind of thing. And what is the mechanism? Water binding ability, hydrodynamic ability, size and shape, everything is together. You will end up with the viscosity, right? Especially gravies, you have seen that the I think sometimes you have seen them කෑම කනවා මම දන්න උයන අයත් ඇති උයන් නැති අයත් ඇති ගෙදර. But if you are, once you cook the meat or once you cook the fish, even meat වලේම ඔයගොල්ලෝ හොඳට දකිනවා ඒකේ පොඩි gravy එකේ thickness එකක් එනවා උයල ඉවර වෙනකොට. So you have eaten it, different type of meat එක chicken එක වුණත් උයලනකොට ඒකේ එනවා පොඩි thickness එකක්. If it is going to reduce more water and once you keep it in refrigerator, once you take it out, and ඒගොල්ලන් දකින්න පුළුවන් නිකන් jelly ගතියක් වෙනවානේ, කෑලි කෑලි කපන්න පුළුවන් gravy එක. So you can it's a brittle nature is there in the gravy. So the reason is because of the gelatin protein is coming out, and therefore the viscosity increase. So you can see the soup, gravies and salad dressing, you can see this situation, and they put the gelatin for increase the viscosity of the product. When we consider about the protein type, the muscle protein, egg protein, so the meat, sausages, cake and bread, when you consider, you can see hydrogen bonding, ionic hydration and water binding. Therefore, especially in the case of meat, sausages, so it's a water binding ability is there. That is why you can see that the juiciness. So once even you fry it, even you cook it, so meat sausages having the juiciness. Again, කනකොට අර කෑලි කෑලි කුඩු කුඩු වෙලා යන ගතිය නෙමෙයි තියෙන්නේ. දැන් පාන් එකක තියෙන ගතියට, පාන් කියන්නේ වේලිච්ච පාන් එකක තියෙන ගතියට වැඩි වෙනස්. සොසේජ් එකක් අතේ කනකොට ඒකේ ටෙක්ස්චර් එක වෙනස්. මේ නිකන් කනකොට ටිකක් වතුරු ගතියක් වගේ එනවා ඇත්තට මේකේ. Because we can add much water, 40ක් විතර වගේ සමහරට වතුර තියෙන්නේ sausage වල. But those are trapped very well because of the water binding ability in the protein. So if you are adding some glutaminase enzyme, likewise glutamine, then you can get the very nice texture of the meat and fish proteins. In the cake, even if you are adding some the milk, small amount of milk or milk powder එක පොඩක් වතුර දිය කරලා add කරොත් එහෙම cake වල juiciness, the dryness is gone, and so you can get some watery nature. Water can වතුරම නෙමෙයි water කිව්වට, but the moist කියන ගතිය, so you can see. Muscle protein, egg and milk protein, milk proteins also, there is a gelation abilities there. I mentioned you earlier also the bakeries, cheese and these things, they having that gelation abilities because of the protein is having the water entrapment and immobilization and network formation ability, especially in the case of cheese formation is because of this one. The cheese, even you can see that the spread cheese is there and the different type of cheese is there. Dry කියන ගතියට වැඩි පොඩි moisture ගතියකුත් එක්ක jelly can texture is there නේ. cheese එකේ තියෙනවානේ පොඩි ඉබුවත් ආපහු එනවා. That one is coming because of water entrapment and network formation ability. So likewise there are the lot of things are mentioned here, and you can see that the protein type is there, the food is there, and the mechanism is there, function is there. Once you go through very detail about you have to study this table actually. For example, let's come to the forming one. You can see whipped topping, ice cream, cakes, and desserts. We are using this egg proteins or milk proteins, especially because they are having the forming ability. But in the case of fibrous protein like meat or fish proteins are not having this forming ability, and therefore we are not going to use it as a topping. So the different situation. But when you consider about the structure of these foods, definitely you can understand this is there. Make a study කරන්න හොඳට ගොඩක් ලාට question එකක් making එනවා. This table එක හොඳට study කරලා, but you have to study it. So if you need any more information, you can discuss with us at the chat session. The functionality of the food protein, physical and chemical properties influence the performance of protein in food system. Those are the during processing, preparation, storage, and consumption. These things can be happen, right? The processing, I mentioned you, the preparation also I mentioned. Storage means once you keep a time being, for example, the gelatin. So at the beginning it's a salt, or you can dissolve the gelatin in water, and after storing only you can see that the entrapment or the jelly will be formed after storing. වෙලාම හැදෙන්නේ නැහැ, ටිකක් වෙලා ගියාම cool වෙනකොට තමයි ඒක entrap වෙලා ඒක set වෙන්නේ. That's the meaning of storage. And the consumption one is you have to the boiled egg or the cooked meat or the cooked milk or the different situation is a consumption. Processing means the dehydration or the baking, those are the processing. And preparation is also we can add some other things together and make the things preparation. So the processing, preparation, storage, and consumption. So all the situation we have to we can see the influence and the performance of protein. So why proteins are important? Because of the nutrition, because of the functionality in the food, right? And how does structure relate to the functionality? So there are the three things: intrinsic factors, extrinsic factors, and processing factors. So the intrinsic factors mean what are the factors of the protein as itself, as amino acid. So as amino acid, as a protein, because of that protein can be change some factors, some mechanism, right? The one is amino acid composition, whether it's a bigger amino acids are there, whether it is a small amino acids are there, whether hydrophilic, whether hydrophobic, whether it is the acidic one, whether it is a basic one, or whether it's a neutral one. So likewise, the amino acid composition. So amino acid protein means peptide chains, basically. Peptide chains mean the different type of amino acid get together. Therefore, the behavior of these proteins are totally dependent on the type of the amino acid composition. But what amino acids are get linked with each other. So therefore, that one is a bigger size or the smaller size, or hydrophilic or hydrophobic, polar or non-polar, or the acidic or basic. Everything is defined by the amino acid composition. Therefore, as the primary one is the affecting protein functionality is the amino acid composition. Second one is confirmation of the structure. That means whether primary, whether tertiary, whether it is quaternary, secondary, tertiary, or the quaternary. So what is the structure? Whether it is a globular protein or whether it is a alpha helix or beta sheet one. So likewise, what is the structure? Because of the structure, it can be changed, right? The other one is, that means if it is the alpha helix structure, that is also it's a rod-like. Therefore, all the bonds are there in between. It's a rod type, and it is parallel to the y-axis. Y-axis එක දිගේ තමයි ඔක්කොම bonds හැදෙන්නේ alpha helix නම්. If it's a beta sheet නම්, always it's the two sheets. Therefore, the sheets are there either horizontally, x-axis parallel to x-axis. Bond හැදෙන්නේ මේ දෙක අතර. It's in the parallel to the y-axis. It's a beta sheet එකේ. then the globular, when you are considering about the globular protein එක වෙනකොට proteins are the alpha sheets are there මේ විදිහට protein යනවා beta sheet එක මේ පැත්තට යනවා මේ දැන් globular වෙනකොට මේ because of this linkage මේ අතර යන වෙනම යනවා මේ අතර වෙනම යනවා මේ දෙක අතර තිබෙන වෙනක තමයි you can see that the globular proteins are formed, right? So the conformation of structure also very much important. ඒකට the linkage වෙන්න තියෙන ability එක වැඩි වෙනස් වෙනවා මේවා කොහොමද හැදිලා තියෙන්නේ කියන එක මත, right? That is the situation conformation of structure. Then the other one is surface characteristic. So the hydrophilicity, hydrophobicity. I also mentioned you the isoelectric point, pH equal pi. No net charges are there, therefore the protein can be precipitated. So if the protein can be precipitated and those are getting together or they coagulate, then totally function will be changed. Therefore, the surface characteristic of the protein, of the amino acids available in the protein is totally depend on the its functionality. Other one is isoelectric point with the pH equal to the isoelectric point. Net charge is no net charge is there, therefore the protein can be precipitated because those are getting together as so the coagulation can be happen. So if it is the negative charges or the positive charges, repulsion is there. Repulsion means those are the proteins not coming together, is going away, therefore the solubility will be increased. Then the conjugated subunits, whether it's a carbohydrates are there, whether it's a lipids are there. Because of subunits that the if it is a lipids, definitely it's a non-polar one. Therefore, the conjugated subunits are definitely decide that what kind of protein is there, what kind of functions can be doing. If it is a non-polar lipids are the non-polar subunits are there a lot, definitely it is having a hydrophobic effect. If there is a carbohydrates subunits, definitely it is a hydrophilic. Carbohydrates are always hydrophilic, right? So most of the carbohydrates. Therefore, you can decide that the conjugated subunits are deciding the functions of the functional properties of the protein. Molecular size, the viscosity, small proteins don't influence the viscosity changes, but bigger one, the smaller proteins are not supporting, but the bigger one are supporting because bigger one ලොකු අයට ඉක්මනට move වෙන්න බෑනේ මහත ලොකු විශාල අය හිමින් යන්නේ නේ ෆිල්ම්ස් වල එහෙම දැකලා දෙන පාර යනවා දැකලා ඇති නේ කො හිමින් යන්නේ චූටි අය නම් මොකද කරන්නේ චූටි ළමයි එහෙම දුවනවානේ ඒගලන්ට එක තැනක ඉන්නත් බෑනේ කොහොමද ඒගලන්ට move වෙලා අස්සෙන් ගිහලා යන්න පුළුවන් so likewise the molecular proteins උත් එහෙමයි if the molecular size ඕන එක පුංචි නම් එයාට ඉක්මනට move වෙන්න පුළුවන් ඒක ලොකුයි නම් move වෙන්නේ හිමින් so therefore then lorry ගොඩාක් තියෙනවා නම් move වෙන්නේ නැහැ ලේසින් lorry park එක car නම් ටිකක් ඉක්මනට motorcycle නම් ඊටත් ඉක්මනට bicycle නම් තවත් ඉක්මනට so these kind of like a protein also having a different units so those are the molecular size is smaller then it can be moved very fast accordingly viscosity changes can be happen. The other one is relative groups. Sulfur groups are there, disulfide bridges are there, calcium cross-linking are there, and different cross-linking it can be happen. It is dependent on the relative groups because the side chain is having because main chain is a peptide chain is not having any sulfide or the different type of carbon, hydrogen, oxygen only having the peptide chain, but all other molecules are there in the side chain. So if there's a sulfur groups are there in the side chain, definitely sulfur disulfide bridges can be happen. Sulfur එකත් එක්ක සම්බන්ධ වෙනවා. sulfur එකත් එක්ක H සම්බන්ධ වෙන්න පුළුවන්. So because of this one, the texture will be changed. Therefore, the functionality එක ගැන ආයි බලනකොට so you can see interesting factors. Amino acid composition, structure, conformation of structure, surface characteristics, isoelectric point, conjugated subunits, molecular size, and relative groups are how those are supporting for the function of the protein. When it comes to the other one, extrinsic factors are the environmental factors. We have discussed this in detail in the beginning of this lecture. The pH, effects of charges and temperature, whether we have mentioned pH is effect of charges. Therefore, the coagulation and the repulsion or the solubility or the coagulation or precipitation can be, it is decided by the pH. Other one is the temperature, denature, the breakdown hydrogen bond rate and amount, whether it's a control pH, the heat. Higher temperature get more hydrophobic interaction, and lower temperature getting hydrophilic interaction. So those things will be decided by the temperature, right? The other one is because it says that the temperature, that the hydrophobic interaction means because of the temperature, how it can be temperature get more hydrophobic interaction, but we can say that example, right? So the once you heat the thing, so the definitely that the water will be removing, because hydrophobic interaction is increased, therefore it is not support for the solubility, therefore breaking down the bonding, and also it is removing the water from the system. Therefore you can see once you heat it, you can see that the water is going out. It's a temperature. The temperature in the both situation. In the other one is that in the freezing even, if you freeze freeze the protein even, you can see once you throwing it, I know temperature bonds break down වෙලා වතුර අයින් වෙනවානේ. Therefore the high temperature as well as the very low temperature, both are breaking down the hydrogen bonds and denature the protein, and therefore you can the water will be removing. Redox status, oxidized and reduced, also break down or the changes the double bonds. And the salting out and salting in, two things are there, but salt in this stage, at the PFS stage, you have to know only the salt is supporting for protein functionality, but need not to learn much more detail. Then solvent type, alcohol, buffer, water promotes protein-water interaction and protein-protein interaction, which gives more aggregation. Because you know that when we talk about the enzymes, definitely that temperature, the pH is really important. If the pH is changed, that means the active sites are not there as way. Therefore, the enzyme activity will be changed. Therefore, the solvent type, for the enzyme activity, enzymes are the protein. To keep that activity, you have to maintain the real and correct favorable pH. And this one is the promotes protein-water interaction, no protein-protein interaction, which gives more aggregation. Therefore, the protein-protein interaction gives the aggregation, and protein-water interaction is given the solubility. Therefore, according to if you add the alcohol or the buffer or the water, that the solvent type, it is changing the protein-protein interaction as well as the solubility and the precipitation, aggregation. The other one is other minor constituents, the carbohydrate, lipids, phenolics, or because those things are available in the system. It is not a minor constituents in not the side chains are linking with the carbohydrate, but side chains are always happy to link with the other molecule. Most of the amino acids you can observe when you are when you can see this when you are checking the amino acid, that the molecule. Therefore, it can be changed like that. It can be linked with each other, right? Accordingly, that these environmental factors change in also the protein functionality. Processing factors: heating, cooling, freezing, drying, concentrating, storage, shear forces, pressure, chemical and enzymatic modification also can change the situation. So processing factors, I have discussed with detail about that, and I think you can understand that. And please learn these things, study these things one by one. මොකද්ද වෙන්නේ කියලා කල්පනා කරන්න. මොකද්ද වෙන්නේ කියලා කල්පනා කරලා when you are preparing your own notes, make example there. මේකෙන් ප්‍රශ්නයක් එන්න පුළුවන්. ඒ නිසා ආවම example දීලා ලියාගන්න. example දැනන් ඉන්න ඕනේ. heating cooling වෙනකොට මොකද්ද වෙන්නේ? කොතනද මේ protein factor එක, how it is supporting for the protein functionality. Functionality ඉස්සෙල්ලා මතක තියාගන්න, මේ ටික තියාගන්න, උදාහරණ තියාගන්න. ওই ටික ඇත්තටම so all the things I have mention you up to now to teach you about the functionality of the protein and how these three things, intrinsic factors, extrinsic factors, and processing factors will be affecting the function. Because the principles of food science we are learning. ඒක නිසා මේ ඒකට තමයි ආවේ. ඒ නිසා දැන් ඔයගොල්ලෝ දන්නවා මේක ස්ටඩි කරන්න, then you will be understand everything, right? So the 9:30 before 9:30 I want to stop the lecture. Certain lecture එකක් ගන්න තියෙන හින්දා මේ කියන්න මට, so the are there any questions?